Determine whether each triangle is acute, right, or obtuse. For it to be considered a right or obtuse triangle, it only needs one right angle or one obtuse angle. But to be acute, it needs all three of its angles to be acute angles. So for example, number 3 has an acute angle, and one obtuse angle. So this is an obtuse triangle. What is the area of this rectangle? Well, remember the formula we've been using for rectangles and parallelograms is base times height. So in this one, the base is 8 feet long and the height is 3 feet tall. So 8 times 3 would give us an area of 24 feet squared. If you cut the rectangle exactly in half, what would you expect the area of each piece to be? So if we cut it in half, what would each piece be? If the total area is 24, we would expect each piece to be 12 because 12 times 2 is 24. What if instead of cutting it in half that way, we cut it in half diagonally? If it's cut in half, does it matter which way we cut it? No, each one would still have to be 12. Even if we cut it diagonally or in half horizontally, each piece would have to be 12, so that our total area comes out to 24. Do you think any two identical right triangles of any size can be composed or put together to form a rectangle? Explain. Well, let's see. If I were to copy this triangle, could I turn it into a rectangle if I compose two of these identical triangles? Can I turn it into a rectangle? Well, if I turn this piece around and put them together, am I able to form a rectangle? Yes, it has a base of 2 and a height of 4. The triangle also has a base of 2 and a height of 4. What about these triangles? Can I make a rectangle with two identical pieces? Two identical triangles. If I turn this piece around and match it up, again, I'm able to make a rectangle. So what do you think the formula for the area of a right triangle is? In the previous lessons, we looked at rectangles and parallelograms as base times height. Well, this has a base of 5 and a height of 4, but it doesn't make a complete rectangle with a base of 5 and a height of 4. It's making a triangle. So how would we have to modify that equation or that formula to think about how the triangle is formed? We would need to split it in half. Another way to write dividing by 2 is if we leave, change, change. So you might see the formula written as half of the base times the height, or you might see it written as base times height divided by 2. These are the two typical versions of the formula that we see. What do you notice about the base and height of each of these triangles? The height and base form a 90-degree angle. This is the base here and the height, and they form a 90-degree angle. This base and this height form a 90-degree angle, and this base and this height form a 90-degree angle. You might also notice that the base isn't always the bottom. Typically, we think of base as the bottom of something, but when we're talking about finding areas of these shapes, we're looking for where they form that 90-degree angle for the base and the height. And sometimes they've rotated that shape so the base is no longer on the bottom. Does it matter if this was the height and this was the base? No, as long as they form that 90-degree angle, we can swap out the base and the height without changing its area. And you can see here that sometimes the height isn't even a part of the triangle or a side of the triangle. Sometimes it's in the middle. So the base is typically a side, but the height doesn't have to be a side. It can fall somewhere in the middle of the triangle or off to the side of the triangle. What we're looking for is that 90-degree angle. I'm going to read a statement. If you think the statement is true, if we were in class, you would stand up. And if it's false, you would sit down. So you're just going to go through and think about whether you would believe these statements are true or false, and then see if you are correct. Any right triangle can be composed into a rectangle with twice the area of the right triangle. So any right triangle, when we have two of them, can be formed into a rectangle. That is true. The next statement. Any rectangle can be decomposed into two right triangles with areas that are each half the area of the rectangle. That is also true. The height and base of a right triangle are always two sides of the triangle. That is false. We saw here that the height was not one of the sides. The height of a right triangle is always perpendicular to its base. Perpendicular means they cross at a 90-degree angle. That is true. The base of a right triangle is always on the bottom. False. We saw the base can show up as the top or the side. There is only one possible height of a right triangle. That is also false, because remember, we can swap the height and the base and still be able to get the same area. Any side of a right triangle can be a base of the triangle. That is true. You can determine the area of any right triangle by multiplying the base by the height and dividing that answer by 2. That is true. That was the formula we wrote down. The height of a right triangle is always a side of the triangle. False. The height can be in the middle of the triangle also. Or sometimes you might see it shown off to the side. You can determine the area of any right triangle by using the formula A equals half of the base times the height. That is true. That is the one that looks like this. For problems 1 through 4, determine the area of each right triangle. Typically, we don't use the X for multiplication when we have letters, so we're going to use that dot for multiplication. Here we have the base is 11.4, the height is 17.7, and then we divide by 2. These two side lengths are connected by a right angle. So 11.4 times 17.7 is 201.78, and we divide that answer by 2, which is 100.89, and area uses units squared. Remember, we talked the other day about trying to fit little squares inside of our shape. Here there are 3 numbers, and that's to try and trick you. We only get to select 2 because we're looking for a base and a height. We just discussed that the base and the height have to form a 90-degree angle, so this 10 is a number there to trick you. It doesn't matter if you use 6 as the base or the height, or 8 as the base or the height. Eight times 6 is 48, and 48 divided by 2, or half of 48, is 24. This one is inches squared. For these, let's change them into improper fractions. 5 times 2 is 10, plus 1 is 11. 2 times 3 is 6, plus 1 is 7. This one, it might be best to use the other version of the formula, where instead of dividing by 2, we multiply by 1/2, since I already have 2 other fractions. So I'm going to replace the base, or the b for the base, with 11 over 2. And I'm going to replace the h for height with 7 over 3, because those form a 90-degree angle. 1 times 11 is 11. 11 times 7 is 77. 2 times 2 is 4. 4 times 3 is 12. For this one, we have a base of 21, a height of 10.5, and then since it's a triangle, we divide it by 2. 21 times 10.5 is 220.5. Half of that is 110.25. Tyler and Blake have rectangular pieces of paper with the same length and same width. So let's make the rectangles the same. 2 identical rectangles. They each cut their paper exactly in half. Tyler cuts his paper horizontally through the middle. Blake cuts his paper along a diagonal. Which student has the half piece of paper with the greater area? Explain. As we discussed earlier, the half pieces of paper have the same area. Regardless of which way we cut it, the area of each piece is half of the total rectangle. Since their rectangles were identical, half of their rectangles will be identical as well for the area, even though they've cut them in different ways. Consider triangle X, triangle Y, and triangle Z. Order the triangles from the least area to the greatest area and explain how you know. So the area, and I'm going to write the little X next to it. X has a base of 1, a height of 5, and don't forget we divide triangles in half. It's half of the rectangle. The area of triangle Y, we have a base of 2, a height of 4, and we have to split it into 2 parts. And the area of Z, it has a base of 3, a height of 3, and we have to split them into 2. 1 times 5 is 5. 5 divided by 2 is 2.5. 2 times 4 is 8. 8 divided by 2 is 4. 3 times 3 is 9. 9 divided by 2 is 4.5. So we need to order them from least to greatest. The least is the area of triangle X. Then triangle Y, and lastly, triangle Z. And how do we know? Well, 2.5 is less than 4, and 4 is less than 4.5. The right triangle has a height of 7 centimeters and an area of 14 square centimeters. What is the base of the triangle? We're going to start by writing down our formula. It says it has a height of 7, so I'm replacing h with the number 7. And it says it has an area of 14, so I'm replacing the A, which stands for area, with the number 14. I still have a variable here, so this is reminding me of an algebra equation. 7 divided by 2 is 3.5, and that is being multiplied by B. On the left, I still have 14. To undo this multiplication, I need to divide by 3.5 on both sides. These divide out, leaving us with b, and 14 divided by 3.5 is 4. So our base is 4 centimeters. The area of a right triangle is 9/16 square feet, and the base is 3/4 feet. Write an equation that relates the area of the triangle to its base and its height, h in feet. Solve the equation to determine the height of the triangle. Since I have fractions, I'm going to use the 1/2 base times height version here. The area is 9/16, so I replace the a with 9/16. The height of the base is 3/4. This is multiplication happening here and here. We're going to combine our like terms. 1 times 3 is 3. 2 times 4 is 8. And we have h there. H is being multiplied by 3/8, so I'm going to divide by 3/8. Remember, dividing by 3/8 is the same as multiplying by the flipped over version. So over here, I need to do 9/16 times 8/3. 9 times 8 is 72, and 16 times 3 is 48. If I divide 72 by 48, that comes out to 1.5. So our height is 1.5 feet. Or you could write it as a fraction, since these ones are fractions. That would be 1.5. A triangle has an area of 20 square inches. What could be the base and the height of this triangle? Well, let's say I make the base 10. 10 divided by 2 is 5. So 5 times something has to equal 20. 5 times 4 is 20. So the base could be 10 and the height could be 4. Let's try another one. What if I made the base 5? 5 divided by 2 is 2.5. Then I would solve it by dividing by 2.5 on each side. H comes out to 8. And these would be measured in inches. There are several different possibilities besides what we have here. But ultimately, our base and our height multiply to make 40. 5 times 8 is 40. 10 times 4 is 40. Because then when we divide by 2, 40 divided by 2 gives us 20. Miss Song makes a quilt. She makes the design in the corner of the quilt from 8 right triangles as shown. Each triangle has a base of 4 and a height of 10. What is the total area of the design in the center of the quilt? Explain. The base is 4. The height is 10. 4 times 10 is 40. 40 divided by 2 is 20. But it says she makes 8 of those. So I need to do 8 times 20 to figure out how much the total area of all of those triangles is. That is 160, and that was measured in inches, and area is inches squared. There are 4 identical shelves in the corner of a room. The top of each shelf is shaped like a right triangle with a base of 11 and a height of 11. 11 times 11 is 121. And if we divide that by 2, that gives us 60.5. But I need 4 identical shelves to find the total area of all the shelves. And that is 242 inches squared. The sunshade shown is in the shape of like a right triangle with a base of 18 and a height of 20. 18 times 20 is 360. Divided by 2 is 180 feet squared. The sunshade costs $75. About how much does the sunshade cost per square foot? So $75 was the total. And if we break it up into 180 square feet, how much does each one cost? And that is about 42 cents. Comes out to 0.41 and 6 repeats. So we'll round up to about 42 cents per square foot. That's all for lesson 2.